morning, dear. How are you? Yes. Dear, how are you? Do you have any problem related to previous sessions? Tell me fast. Yeah, good morning, Balak. Milan, okay, I am waiting. Rao Rakesh, mechanical. Okay, whatever this class related to electrical. Okay. Yes, so baby Balak, good morning. Yeah, so you don't have any doubt. Okay, so in this session now we will discuss switch module. What is actually a switch module in power electronics, and what are the main applications of the switch module to design different types of converter? This is the object of today's class. Now, we will not learn only how to draw the VI characteristics of the switch module, as well as we will try to cover why we require switch module to design different types of power electronics converter. For example, AC to DC, DC to DC, DC to AC, and AC to AC. We have a lot of choice to select the devices for our particular converter. So my dear friend, basically, what is the power rating of the converter is going to decide, see the sentence, whatever the power rating of converter we require is basically to decide the selection of device. Basically decide the selection of device is one thing. Okay, if somebody will ask you simple question, what is the need of switch module? Okay, what is switch module? We will discuss. What is the need of switch module? First, I want to tell you. So we have different type of converters. First thing, what will be the power rating of converter? That thing is going to decide which type of power electronic device we require to design our converter, is the first thing. Now second thing, in how much time period one cycle we want to complete. Let us assume, my dear friend, in the chopper we want to complete one cycle within some millisecond or microsecond, even less than millisecond. In general, the one cycle period in the DC to DC converter in general not more than 1 millisecond. And with respect to it, the switching frequency will be kind of, or the one cycle frequency kind of 1 f is equal to 1 by t, so hardly is 1 kilohertz or more than this. Similarly, in inverter, to control the harmonics component, we require different type of devices. And obviously, to control the harmonics component, we require high switching frequency of devices, so easily can provide sinusoidal pulse width modulation and space vector technology to control the harmonics component of load voltage as well as load current. But in AC to DC converter, due to the high power rating, and our Indian standard supply is 50 hertz, so the time period will be 20 millisecond. According to that, we require different type of power electronic devices. So actually the switching frequency is the next most important parameter before the consideration of any converter with respect to designing of switch module. So what are the two things to decide the switch module configuration? One is how much power handling capability we require from our converter, and the second most important thing, switching frequency. At what switching frequency we want to operate our switches, whatever are used or to design our any converter. So these 2 points are basically most important. And our third point is also not negligible. That is nothing but how much switching losses and conduction losses is going to take place in the converter. So whenever we want to control switching losses as well as control conduction losses, again we have some limitation to select our device. Randomly we cannot select. So let us assume we want to operate one particular device for the 20 millisecond time period, and we require power handling capacity moderate type or low, then MOSFET can be the best choice, because it will introduce low switching losses. We want to turn on hardly one time in the period of 20 millisecond. So this is the thing. But if we want to turn on or turn off our MOSFET more than 1000 times or 100 times in the 20 millisecond period, then obviously on off switching losses will be very high. So according to the application or requirement, we have to select our power electronic devices to design any converter, and the selection of power electronic devices in some particular manner, either in series or in parallel, is called switch module. Now my dear friend, tell me, all the points are clear to everyone? Yeah, everyone, tell me please. Vijay and everyone, this thing is clear to everyone? What is the need of switch module? For example, I want to tell you this thing, same thing, with the help of one example. Okay, please be serious at this moment. Let us assume, my dear friend, we want to design one AC to DC converter. In general, we are much familiar with this converter. And in AC to DC controlled converter, let us assume we have 4 SCRs, okay, in this fashion, 4 SCRs. Now, my dear friend, can you tell me simple thing? I want to ask a simple question. In general, what is the switching frequency of this thyristor? In general, whatever we use in AC to DC converter, as we discussed many times. Can you tell me? Mahabir, sure, I will try to manage, okay? Yeah, first listen to me carefully. Can you tell me, my dear friend, what is the switching frequency of SCR? In general, whatever SCR we use in AC to DC converter, the most interesting thing, the frequency of SCR cannot be more than hardly 200 Hertz or 300 Hertz. So it can be in the range of 100 Hertz to 300 Hertz hardly. And another thing, due to the designing of SCR, we have 4 layers, 3 junctions, and one control terminal is nothing but gate. So the moment at which we will apply some gate voltage in between gate and cathode, gate current will flow near to the gate periphery in this fashion. Near to the gate periphery. Please try to understand. In this fashion. So initially, our SCR current will start to flow in this fashion. And due to this curve, we can say initially, we have huge heat loss near to this gate region. You are getting my point, my dear friend? You are getting my point? Near to this point. So here we have high heat loss. To overcome this problem, definitely we require protection. That protection can be di by dt protection, and in other words, to protect our device from the high rate of change of voltage, we may require dV by dt protection also. So the thing is that in the switching period of SCR, we have considerable losses. That's why we require di by dt protection in SCR. Now, my dear friend, I want to tell you, let us assume we want to design this converter not for high power rating. We want to design this converter for low power rating. Okay, this is the first thing. Now, can we replace these SCRs by any other device? Do you have any choice? Can you tell me? Yes. Think over it and tell me, everyone. Please enjoy the session. Don't try to just listen. Involve, or please provide your involvement 100% so that we can discuss each and everything related to switch module. Yeah, do you have any doubt? Or can you tell me which type of devices, by which type of devices we can replace our SCRs, whatever we are using in AC to DC converter for the low power rating? So first thing, many times I told you, the SCR is bipolar device, will have a capacity to block high positive voltage as well as high negative voltage. And that's why SCR so popular in AC to DC converter. My dear friend, we don't have second choice. for high power rated AC to DC converter except SCR. If somebody will ask you in interview, can we design AC to DC converter high power rating by any other device? Obviously, answer is no. Because only we have single choice SCR, silicon controlled rectifier. But what about low rated or low power rated AC to DC converter? We have many choices. We can use MOSFET, we can use IGBT, we can use any other devices. So we have a lot of choices. But the most important thing in AC to DC converter, mandatory thing, power electronic devices should have capacity to block both voltages, either positive or negative. Because my dear friend, if we want to control the cycle at any instant, then we will not trigger our devices before our requirement. And in this period, our devices will behave like an open circuit. So our entire supply voltage will block by those devices only, whatever we will use to design our converter. You are getting my point? So here we have many choices. For example, okay, yeah, Vijay, diodes is not a good choice, okay, at this moment, because we want to design controlled converter, and with the help of diode, we can design only uncontrolled. So my dear friend, now we know that the most important thing, MOSFET, we have another choice. MOSFET, we have another choice. And I want to also take IGBT in this fashion, okay. Now everyone knows it, I think. MOSFET are useful at low power rating. At low power rating in terms of hardly 1 kilowatt or 2 kilowatt, whereas IGBT much better than MOSFET in terms of power handling capability, more than 2 kilowatt, or we can use up to 5 kilowatt. Okay, we can use up to 5 kilowatt. Yeah, tell me, it is clear, dear? So see, whenever we want to design AC to DC converter for very high power rating, choice is only SCR. When we want to design AC to DC converter for low power rating, choice can be MOSFET, and for moderate power rating, choice can be IGBT. But my dear friend, MOSFET and IGBT can block only positive voltage. You are getting my point? What is the meaning of to block positive voltage? Means they are not capable. That means IGBT and MOSFET are not capable to block any high negative voltage. Okay, but SCR can block, because when we will apply any positive voltage across SCR, it will not get turned on until or unless we are not providing gate pulse. And similarly, if we apply negative positive, SCR will be reverse biased, and the junction J1 is responsible to block your entire negative voltage, and this body will work as an open circuit. But this thing we can't achieve either in MOSFET or IGBT. So definitely we require some modification whenever we want to design AC to DC converter with the help of MOSFET or IGBT, so that our new device combination can block both voltage whatever we require, either positive or negative. Tell me, this thing is clear? And also tell me, my dear friend, how we can achieve this job. Okay, what we can do with the MOSFET and IGBT to make these switches like as a bipolar switches. What is the meaning of bipolar? Not electrons or holes. Here bipolar means those devices must be capable to sustain either polarity of voltage, either positive or negative. Okay, so think over it and tell me. So just 7 months ago in YouTube I watched a movie, but I know I got love with gate videos. I watch all crash courses. बहुत मजा आता है. Okay, thank you, dear. Okay, so now tell me, do you have any choice? Yeah, very nice. So they use diode in reverse. Okay, very nice. So I want to say, or I want to follow your friend's suggestion, beta. Here your friend is saying, sir, use one diode. In which fashion I want to ask? In which fashion, my dear friend? Either in this fashion, or we can say either in this way. Okay, either in this way. Which is correct one? Okay. Yeah, either first one is correct or second one is correct. Think over it. Similarly, from your from suggestion of your friend, I want to consider one diode with IGBT also, my dear friend. In this way, and again we have one more IGBT in this way. Now tell me, which connection will be correct, in IGBT or in MOSFET, either first or second? Yeah, everyone, think over it and tell me. See, nobody knows it. Okay, nobody knows it. How we can achieve that type of job to design AC to DC converter, especially when we want to control switching losses and conduction losses, as well as we want to control harmonics in AC to DC converter, supply side harmonic, so that easily we can provide, my dear friend, sinusoidal pulse width modulation. This sinusoidal pulse width modulation really not easy with SCRs, So please keep in mind, okay? Yeah, very nice. So this first one is correct, okay? First one is correct according to your friend. My dear friend, see properly. If I want to select this first one IGBT or second one IGBT, see properly. The moment at which we want to turn on our IGBT, diode will not give conduction because it is connected in reverse biased. And to design AC to DC converter, as I told you many times, the SCR VI characteristics will look like something. Okay, please be serious at this moment. Will look like something. So this can block positive voltage as well as negative voltage and can pass positive current. So we require our switch module in this fashion so that our devices combination can block both voltages and can pass single direction of current, or direction only in single, current only in single direction. This is the point. Now, my dear friend, if this IGBT we want to trigger, but this diode will never conduct with IGBT, in opposite way, when diode will conduct, IGBT will never conduct. So such type of conduction or such type of like switch module will never provide us conduction. So it is not valid. In the same way, my dear friend, when this MOSFET will get turned on, obviously diode will not. And when diode will get turned on, obviously MOSFET not. So it is not correct like switch module. What about this one? When MOSFET is on, diode will also on. And when MOSFET is off, diode is also off. So my dear friend, in this case, we can design something. Okay. Similarly here, when IGBT is on, diode is on. When IGBT off, diode is also off. So we can use such like of switch module. So either this one is correct, second one, and here first one is correct. So what is the main object? Please mind it. What is the main object? Main object is nothing but we have to fabricate, my dear friend, more than one devices to design switch module. My dear friend, if we are considering same type devices either in series or parallel, in general our power electronics world never consider or don't want to consider such type of combination like switch module. In general way, we can say that is also switch module, but we don't want to use this word switch module to represent, let us assume we have 10 diodes in series connection. So this is kind of not switch module. Switch module means basically we want to introduce more than one power electronic devices which are going to operate at different frequencies. And in the switch module combination, few devices we may have controlled and few devices may have uncontrolled also. Why we want to design such type of devices, we will discuss sometime later. So now the main object to design a switch module is nothing but, as I told you, to control the switching frequency, to control the switching losses, to control the conduction losses. Actually, it depends upon the how much power rating we require to design our converter. Okay. So basically the thing is that to design the switch module, we must have the knowledge of all the power electronic devices in terms of power handling capacity, switching frequency, switching losses and conduction losses. So that with the help of modification, we can control all the parameter whatever we require. And obviously the switch module sometimes require less protection in comparison to normal devices. So that's why switch module somewhat more popular, okay, especially in the low power rating converter or moderate power rating converter. Hopefully this thing is clear. So till now, my dear friend, can you tell me, do you have any doubt? Do you have any doubt? So I want to write, my dear friend, first thing here, okay, what is the definition of switch module? Okay, so please just keep patience around for 1 minute. And please keep this point in your mind. What is the definition of switch module? Switch module, it is the combination of power electronic devices in either series or anti-series or parallel or anti-parallel Okay, so it is the combination of power electronic devices either in series or anti-series or parallel or in anti-parallel. Okay. Now, my dear friend, especially to design low power rating or moderate power rating we require switch module. Next time I will write switch module like this, SM only. Okay, SM only. Now tell me, it is clear? Now what about next thing? So I want to write to control harmonics. My dear friend, please write down. To control harmonics of supply or load. Okay. And switching losses or controlling losses, conduction losses, we modified power electronic devices in terms of switch module. So now these are few points you have to keep in mind. But sir, we use diode for blocking negative voltage. Sir, can we explain one time more combination of MOSFET and diode? Vijay, we will discuss all the combination in detail just after hardly 1 or 2 minutes. Okay, just hardly 1 or 2 minutes. Now, so these are the point. Just keep in mind all the points, because this time they can ask, or they will ask MSQ type question also. So they can give you one option related to switch module also. So what is the advantage or what are the drawback of switch module, we will discuss. Here we have discussed why we require switch module. Okay, this is the first thing. Hopefully all the points are clear. So now, my dear friend, we have many types of connection to design switch module. Many types of connection. Okay. So first I want to write, please mind it, parallel, wait a minute, switch module in parallel, okay, connection of different power electronic devices. Okay, so switch module in parallel. Please be serious. So which how many types switch module we have in market, either in series or in anti-series or parallel or in anti-parallel. So all the devices configuration we will discuss step by step. So first I want to discuss, my dear friend, parallel combination of different devices. Now let us assume we have one BJT in this fashion. Try to understand BJT, where, my dear friend, everyone knows is this BJT is controlled device. Please try to understand, this BJT is controlled device, okay, whereas diode is uncontrolled device. Hopefully this thing is clear. So now this switch module will be the combination of controlled and uncontrolled. And I want to say some terminal A here and B here. Now, controlled one and uncontrolled one. So due to this thing, that type of switch module always called active switch module. Active switch module. What is the meaning of active switch module? Means our switch module will have or must have at least one controlled device. What is the meaning of active switch module? At least, please mind it, at least it has one controlled device. If somebody saying to you that person is going to use active switch module, it means that particular switch module must have one controlled device. At least. More than one may be possible, but at least we require one. At least we require one. Okay? Yeah, now tell me, dear, each and every point clear? Yes. Now see, beta, what is the purpose of switch module, especially for the GATE examination? They will ask you what will be the VI characteristics, how much conduction losses, what are the VI characteristics, how much conduction losses, how much switching losses can appear in the switch module. And then we can compare whether our switch module is better or single device is better by this approach. See, yeah, everyone knows it now, beta. Everyone knows it now, dear. What is? How we can, or what is the selection procedure to use power electronic device to design different type of converter? Obviously, the most important thing, switching losses, conduction losses. If the switching losses and conduction losses are really small or low in comparison to our single device, then definitely we have to use switch module. So that's why switch module are really very popular nowadays in spite of using single device. As I told you, to design AC to DC converter, why we require SCR? It is not mandatory, my dear friend. We can use IGBT to design AC to DC converter. We can use MOSFET. We can use BJT as our requirement. But the most important thing, if you are replacing all the SCR by MOSFET or IGBT, then definitely your new converter must have low switching loss, low conduction loss, low protection, etc. So that your new converter must be economical in comparison to previous converter, whatever designed with the help of SCRs. Only then we can say, yeah, my dear friend, the switch module is better than our main device. This is the thing, or this is the reason behind to design switch module, especially for different type of converters. Okay, hopefully all the points are clear. Yeah, sure. Oh, okay, Anik, definitely we will discuss. So what is the meaning of single pole double throw and double pole double throw? It is really very easy to explain this thing. Okay, so single pole single throw and double pole double throw, I will write here. So first thing, my dear friend, do you know the mechanical switch presentation? The mechanical switch presentation is something like this. Okay, so let us assume this is terminal A, that is terminal B. And my dear friend, please be serious. Here, this is the throw. This is called throw. Okay, this is called throw, my dear friend, and it is called pole in electrical word. This is some mechanical switch. So here we have single throw and a single pole. So whenever this throw will connect at this pole, our switch will conduct. And when this throw is not connected with the pole, our switch will be off. So in this case, we have single throw. This is single throw and single pole. So that type of switches are called single pole, single throw switches. When we have maybe our switch in this fashion, my dear friend, okay, here like this. So we have single pole, single throw at this moment, my dear friend, and double pole. So sometimes this throw is connected at this location P1, sometimes it is connected at PT. So that type of switches are called single throw, double pole. Okay, similarly we can write, my dear friend, like this also. If we have two throws in this fashion, suppose I want to say this is some T1, this is some T2, and here I have single pole, my dear friend. So for some time this switch or this T1 terminal is connected with P, and then T2 is connected with P. So in this case, how many number of throws we have? 2 and single pole. So it is called 2 it is called like double throw and single pole. Okay, and obviously in this fashion we can decide or we can say about the other devices. Okay, now tell me, it is clear? Very nice. Now my dear friend, what is our main object? Main object to design the VI characteristic of this switch module. So please be serious and write on the heading VI characteristics of ideal switch module. Okay, in this particular case I don't want to consider directly example with you, my dear friend, because before discussing the example I want to tell you, sir, these switches can be done by SCR BJT diode. Yeah, my dear friend, obviously we can done. Obviously, how I will tell you. Okay, I will tell you. So see, my dear friend, VI characteristic of ideal switch module. So here we have one switch, controlled one in this fashion and uncontrolled this one. Please be serious. We don't require more than 5 minutes to explain the VI characteristic of this switch module. Okay, so it is our like a base, and you know very well. So this device is a BJT and that device is diode, and overall combination is called switch module. Please everyone tell me till now each and everything clear, so that I can explain more things about the like switch module. And meanwhile, if you want to, you can share this video with your friends. Okay, and as well as if you're liking this session, then it will be good. Okay, so if you are enjoying this session, then only. Yeah, very nice. Now this is the BJT with anti-parallel diode. Can I ask you very few things, okay, before discussing this? Can you tell me with everyone what will be the VI characteristics of ideal BJT? Ideal BJT. I want to ask very easy question. Ideal BJT. For you, beta, I want to give you few options. Like for example, A, B, C and D. Okay, A, B, C and D. Here I want to write I and V. Here I want to write I and V. Here I want to write I and V. Similarly, I and V quadrant system. Okay, so now I want to show you the VI characteristics for this. So it is your option something, it is your option this one or that one or this one. Can you tell me, my dear friend, which option can be correct? I want to write some name. It is A, it is B, C and D. So which option can be represent the VI characteristic of ideal BJT? Everyone please tell me. What will be the VI characteristic of ideal BJT? Plus I plus V minus V plus I obviously, plus V and minus V and plus I obviously. Here plus V minus I and plus I. This is the thing. Yes, everyone tell me please. Yeah, so done. Yeah, everyone tell me beta, what will be the VI characteristic of ideal BJT? I want to know answer from your side. Yeah, see, only BJT, option A. Very nice. Very nice. My dear friend, definitely option A is correct. Only for BJT. Similarly, can you tell me, my dear friend, the diode VI characteristic? The diode VI characteristics. So this is the, it is really very easy. This is the beta VI characteristics of BJT, ideal BJT. And here, this is the VI characteristic of ideal diode. Ideal diode. So see, my dear friend, BJT can pass positive current, diode can pass positive current, BJT can block positive voltage, diode can block negative voltage. Diode can block negative voltage. Okay. Now this type of VI characteristics knowledge we must have before discussing this switch module. Before discussing this switch module. Okay. So now I will tell you every step in detail and in minimum time also. Okay. Now my dear friend, I want to ask you very easy question. We want to draw VI characteristic of this complete switch module, not alone or separately BJT or not separately diode. We want to design entire VI characteristics. For that, I want to tell you a simple thing. Let us assume, my dear friend, here we have some voltage V applied across the terminal A and B. Now, can you tell me, my dear friend? Everyone, listen to me carefully. If the positive voltage here negative, numerical way, let us assume beta it is 10 volt. In between A and B, we are applying 10 volt. Can you tell me, dear friend, diode can turn on or not? Think properly, because we want to learn. That's why I need responses from your side at every moment. Okay. Yeah, think over it and tell me. When this voltage A terminal is connected with positive, B terminal is connected with negative, then this diode can turn on or not? I know you will reply, yes sir, obviously never. Why? Because my dear friend, this positive sign will come here and this negative sign will come here. So anode is negative and cathode is positive. So we can write one thing. When this A terminal voltage is at higher potential and B terminal voltage is at lower potential, then diode cannot conduct. So I can write one thing, my dear friend. When VAB, this voltage beta, VAB is greater than 0, diode will off, cannot conduct. Why? Because it is reverse biased. Because it is reverse biased, and in this universe nobody can provide conduction through BJT in the reverse biased. If you will apply excess voltage across the diode in the reverse mode, definitely diode will get damaged. So what I want to tell you, the reverse conduction of diode is kind of impossible. If you will excess voltage or provide excess voltage, it will get damaged. So obviously diode is a unidirectional device. The current can flow only anode to cathode. Hopefully this statement is clear to everyone. Yeah, yes. No dear, no issue beta ji, please. Now beta, I want to ask another thing. When we apply positive voltage here, negative voltage here, in other words, the collector of this BJT is at high potential in comparison to emitter. In comparison to emitter, collector is this one, emitter is this one. Similar to this diode, it is anode and this one is cathode, like this. So when collector is at high potential, emitter is at low potential, and we are not triggering the base of BJT, then tell me beta, BJT will on or off? Think properly. BJT will on or off? We are not providing any base current. We are not providing any base current. But the collector voltage is higher than emitter voltage. In other words, VCE is greater than 0. My dear friend, BJT is controlled device. Nobody can turn on without providing base current. Okay? Because that base emitter junction will be reverse biased totally. And for the conduction, all the junctions, that means 2 junction, whatever present in the general BJT, and 3 junction present in the power BJT. So all the junction must be forward bias for the conduction of BJT. And that job we cannot complete without base current. So my dear friend, if you are not applying base current to the BJT, nobody can turn on this BJT anyhow. Okay? Although, my dear friend, if you apply the base current, in other words, positive base current, definitely your BJT will get turned on if condition is there, the collector voltage is still higher than the emitter voltage. But unfortunately, at this moment, when we don't want to apply any base current, but the collector voltage is higher than emitter voltage, BJT will not turn on anyhow. Okay? So the thing is that here I want to write when VAB, yes, please be serious at this moment, when VAB is greater than 0, but we are not providing base current. So the base current of BJT is 0. That's why BJT is also off. That's why BJT is also off. My dear friend, see, very nice, very nice. Okay? Now, my dear friend, see properly. BJT is turned off or BJT is commutated due to our choice. BJT is commutated due to our choice, but diode is commutated due to circuit condition. Due to circuit condition. So lot of difference we have. BJT turn off because we don't want to turn on, whereas diode turn off because nobody can turn on. This is a thing. But still, what will happen in this case? When we are not going to provide any base current, BJT and diode both are off. So my dear friend, no current will flow from terminal A to B or B to A because both devices are off. In this case, what will happen? This 10 volt voltage or 1 kV voltage or any other voltage, whatever you want, will block by either BJT or diode because both are connected in parallel. Both are connected in parallel. So if you will apply some voltmeter here, the devices are reverse biased. My dear friend, it is really very easy to say. The device's junction will block your entire voltage, whatever you will apply across A and B. So in this case, what will happen? No current will flow, but voltage will block. Which voltage will block? Beta, positive voltage will block. Positive voltage will block. So can we draw one VI characteristics of this switch module in this case when both devices are off and voltage is going to block? In other words, our switch module will work as an insulator, not as a conductor. Now see, what is the most important thing? In this case, my dear friend, no current will flow. I and minus I both will be 0 at this moment. Okay, but some voltage will flow and some voltage will block, and that voltage is nothing but positive one. So in this region, whenever our VAB positive, diode is reverse, we are not providing BJT triggering, so all devices are off. So this is the kind, please mind it beta, this is kindly minded, this is the off state of our switch module. This is the off state our switch module. Please tell me, till now each and everything clear? Sir, one silly question, why we use PN junction diode, not Schottky diode in the switch module? My dear friend, we can use Schottky diode, but for very low power rating. Very low power rating, not more than hardly 100 watt or 200 watt. So that's why Schottky diode are really so popular in analog circuits, not in power electronics. Okay. So whenever you want to design any power electronics converter for low power rating, for example 100 watt, 60 watt, 200 watt, then Schottky diode is the best choice in comparison to any other device in terms of uncontrolled, okay. Yeah, very nice. Now I want to tell you next thing, my dear friend. If we want to turn on our switch module, again I want to take this combination, my dear friend, BJT, and obviously one diode is there, and here this voltage still is positive in this fashion. Roughly I want to write 1 kV. Okay. Now what will happen, my dear friend? Please be serious. Here I want to say base current. Still, my dear friend, plus is here, minus here, so diode is reverse biased. So no current will flow here. But now we want to provide base current, I base is not equal to 0. So the moment at which we will provide base current, BJT will turn on and ideal BJT will work as a short circuit. And here I want to write terminal A and B. If I want to connect, my dear friend, one ammeter here, then ammeter will show you some current, and obviously this current will not equal to 0 because your BJT is on. So in this case, my dear friend, current will flow from terminal A to B. So current will flow from terminal A to B. A to B, I want to say, my dear friend, current positive. So IAB will not be equal to 0, and I want to say beta IAB is positive for time being. It is very easy, like similar to circuit theory. I want to say if the current is flowing from terminal A to B, so I assume this current is positive, just this thing. Okay. So what will happen in this case? In the second case, when we trigger BJT, my dear friend, really it is easy to define. The current will flow positive. The current will be positive and BJT on, so it is short circuit. So what will be the value of VAB? Due to short circuit, the value of VAB will be 0 volts. So no need to show any voltage. Because voltage is 0, but current is non-zero and positive. So this is the one characteristics, and it is possible only when BJT is on. This is the thing. So till now we have actually drawn the BJT characteristics. What will happen if we change the polarity across switch module? Like this, my dear friend, if we have some BJT in this fashion again, and this is our diode, and now I want to tell you, my dear friend, we have some minus voltage. Okay, I want to say minus 10 volt, in this fashion 10 volt or 1 kV or any other. Then what will happen? Here this negative voltage will reach here and this positive voltage will reach here. We know that diode is an uncontrolled device. So definitely positive voltage is at anode, negative voltage is at cathode. So definitely diode will get turned on. diode will get turned on, and once the diode on, my dear friend, this total body will work as a short circuit. This total body will work as a short circuit, and now current will flow. Now, my dear friend, current will flow from terminal B to A. You are getting my point? Because diode will never pass negative current. So this current, according to your switch module, my dear friend, is flowing B to A. Is flowing B to A. That is the point. Now tell me, it is clear here, Betaji? Yeah, everyone tell me. Yeah, very nice. So now, my dear friend, when this diode is on, what will be the VAB voltage? Obviously, it is short circuit. So VAB value is 0, ideal case. And current will flow B to A. Earlier, current was flowing A to B. If we assume IAB positive, then definitely, my dear friend, IBA will be negative. IBA will be negative. So here, what will be the VI characteristic in the second case or third case? We can say, my dear friend, here the current will flow in negative direction when we will just change the polarity. Now see the most important thing, Balak. When we apply positive voltage, BJT is not going to turn on until or unless we are not providing BJT base current. So BJT off, and obviously diode reverse bias, so it is also off. In this case, our switch module will block positive voltage. Now we trigger BJT, so current will pass from A to B terminal. I assume this current is positive. Now, when we apply negative voltage, we don't have control over the switch module because diode is connected. So the moment at which our polarity will be just change, we can easily say, my dear friend, diode is on. And when diode on, short circuit, no voltage, but current will flow in upward direction. Can you tell me one thing? Diode is unidirectional device or bidirectional device? Please tell me. Diode is unidirectional device or bidirectional device? Application wise. So my dear friend, diode is unidirectional device and BJT is also unidirectional device, and both are unipolar also, because diode can block negative voltage, BJT can block positive voltage, and they can pass current in positive direction. So what is the advantage of this switch module? If we want to pass current in both direction, then we can use BJT and diode in anti-parallel. So what is the beautiful thing behind the switch module? It will work as a bidirectional. So whenever we require current in load or anywhere in both direction, we cannot use single BJT. We cannot use single diode. So we can use the BJT and diode in anti-parallel. So that's why this switch module is somewhat better than our other devices at this moment, means diode or BJT, okay, in terms of application. Now, how we can control switching losses and conduction losses, we will discuss sometime later, okay. Yeah, very nice. So now tell me, dear, all the points are clear to everyone? Now, similarly, I want to draw or I want to discuss, my dear friend, another thing with you, okay. What is this thing? See properly. Again, draw the VI characteristics of switch module, okay. So example I want to write here, draw VI characteristics of switch module, okay. Given switch module. The given switch module is something like this. We have one BJT, my dear friend, and another diode like this. So this is terminal A, that is terminal B, okay. Now can we discuss directly this switch module characteristics? Switch module and power switch module same or different? No, my dear friend, switch module and power switch module both are same in the power electronics, okay. In the power electronics both are same everywhere, okay. Now please tell me, Betaji, all the points are clear till now? Now here listen to me carefully. to draw the VI characteristics of this switch module is really not tough at this moment, because we have discussed already the previous switch module in detail. Okay, now I will ask you few questions to all of you, and according to your replies I will draw the VI characteristic of ideal switch module. So first I want to draw fourth quadrant system, my dear friend, here. So this is V, this is I. Okay, this is I. Now first question, my dear friend, everyone listen to me carefully and tell me, if we apply positive voltage here, negative voltage here, but we are not applying base current, the base current is 0, then tell me this switch module will be on or off? Simple question. This switch module will be on or off? Think over it and tell me. Okay, meanwhile share this video with your friends and give thumbs up if you feel better. Okay, yeah, very nice. See, my dear friend, what I told you, if we are not providing base current, nobody can turn on BJT. My dear friend, here base current is 0, so BJT guaranteed off. BJT guaranteed off. This pair is kind of true love. Is if BJT off, guaranteed diode is also off, because it is the series connection, my dear friend. If I want to say here 10 ampere current, then definitely here also we have 10 ampere current. So if the base current BJT is 0, the BJT is off, and whatever voltage we will apply here, that voltage will appear beta across the terminals A and B, across the terminals A and B. Now I want to tell you very easy things beta. What is this thing? Let us assume, for time being, let us assume we apply some voltage across terminal A and B, something 1 kV, and we are not providing base current, so guaranteed our BJT is off. In this case BJT is off, and if BJT off, guaranteed, my dear friend, diode is also off. So in case 1, I want to write when VAB greater than 0, and base current I base is 0, so both devices BJT and diode are off, This is the thing. Okay, so the most important thing. So here I can assure you that, my dear friend, when we apply positive voltage here, negative voltage here, or potential difference positive, our devices will not get turned on until or unless we are not going to make IB not equal to 0. So here our both devices are off. One thing. Now I want to ask you a very easy question. Let us assume, my dear friend, we apply positive negative 1 kV voltage here, and I want to tell you some voltmeter is V1 connected here and the voltmeter V2 is connected here. Then what will be the reading of voltmeters and voltmeters V1 and V2 in theoretical way? I will accept like answer of your question with 20% plus minus error. 20% plus minus error. So don't think you have to give proper or absolute correct answer. Just tentative answer I need from your side. If the both devices are off, that means diode and BJT will work as an open circuit, and the reverse bias junction is going to block your voltage. Obviously, like a reverse bias junction will work as an insulator. So at this moment you think properly. What will be the reading of V1 and V2 if we are going to apply 1 kV voltage in between A and B terminal? Yeah, think over it and tell me. Yes, everyone. Yeah, try to understand, my dear friend. See, 1 kV if error is neglected. 1 kV means which voltmeter? V1 and V2 voltmeters reading we have to tell. V1 and V2 voltmeters reading we have to tell with plus minus 20% error. No issue, no big issue. Very nice, very nice. It is absolutely correct. Why I want to tell you, beta, absolutely correct, because we know that, see properly dear, we know that what is the VI characteristic of BJT and diode. The VI characteristic of BJT will look like this, and the VI characteristic of diode will look like this. Okay, BJT and diode. So see my dear friend, BJT can block positive voltage, diode cannot block any positive voltage. It is free from. So my dear friend, if you will apply positive voltage across this switch module, then only BJT is responsible to block your entire positive voltage. Why? Because my dear friend, if some positive voltage will appear across diode, will get turned on, and it is impossible because your BJT is off now, so diode cannot turn on. And diode even cannot block positive voltage. So whatever voltage you will apply across this switch module, that positive voltage is blocked by only BJT, because it is a BJT responsibility. BJT cannot block negative voltage, diode cannot block positive voltage. So BJT must sustain that much of voltage whatever you will apply when you want to turn on or turn off or commutate your switch module across the terminal A and B. And if that voltage is positive, then responsible device is BJT. So my dear friend, the V1 voltmeter V1 characteristic is nothing but 1 kV, is another most important thing. Okay, is another most important thing. My dear friend, never say if 3 devices are connected in series and all devices will have different VI characteristics. So according to those VI characteristics, we can say which device is really responsible to your applied voltage, to block your applied voltage. Not all devices will block. So if the devices are off, it will never give you guarantee that all devices will block voltage. No, it depends the blocking capacity of that device, whether those devices are capable to block positive voltage or they are capable to block negative voltage. That is the only thing. Hopefully all the points are clear to everyone. Now tell me. Yeah, now tell me my dear friend, it is clear. Now, what is the next thing? Please be serious at this moment. The 1 kV positive voltage will block by BJT and BJT off because base current is 0. Then what will happen, beta? So current is 0, the current is 0, but BJT is going to block your entire voltage. So VAB will not be 0 and VAB will be positive. So here we can draw the VI characteristic of the switch module. So my dear friend, it is really easy. Here we can draw this one. So when BJT and diode both are off, our current will be 0 and voltage will be positive. So I want to write plus V something. Now what is the next thing? My dear friend, see properly, here only it is possible. If we want to trigger BJT and now this time base current is not 0 and this is positive, this is negative, my dear friend. So BJT on and just BJT on, some positive voltage will flow here, will come here. So diode is also on. So the moment at which we will trigger BJT and diode both are on, and if both are on, then current will flow A to B, and due to short circuit, our switch module will not block any voltage. Hopefully this thing is clear. Please tell me. So what is the thing here? When we trigger our BJT, some positive current will flow, but no voltage will block. Tell me, it is clear? Yes, please, everyone. It is clear? Yeah, please, everyone. Yeah, sure. Very nice, very nice. Now, the last part I want to ask you, beta. Last part I want to ask you, okay, what is this thing? In this case, last part I want to show you again our switch module. Okay, so this is, dear friend, BJT, and here we have diode, and this is our base. I want to apply here minus plus some voltage. It is A, it is terminal B, and this voltage roughly I want to say 1 kV. Now tell me, if you will not provide IB equal to 0, then this switch module will be on or off. Everyone tell me. If we are not providing this base current, my dear friend, this base current is 0, but we are providing some negative positive voltage 1 kV, then this switch module will be on or off. Everyone please, will be on or off. I need answer from your side. Will be on or off? Yeah, very nice, very nice. So here, my dear friend, what will happen when base current 0 and this is negative positive voltage, so BJT is off. One thing. Now I want to tell you, or I want to ask you easy question again. This time base current is not 0, but this polarity is same. Negative positive 1 kV, but base current not 0. Now tell me, BJT will get turn on or not? BJT will get turn on or not? Yes, think over it. And my dear friend, if you are capable to reply answer of this question, now I can say you are familiar with switch module. You are familiar with switch module. Okay? Yeah, think over it. Is still on, like still off, or it will get turned on? If we provide some base current, but this voltage is negative. But this voltage is negative. Yeah, very nice. My dear friend, still it will not turn on. Why it will not turn on? Because this negative voltage is there, and this negative voltage will never responsible for the conduction of BJT as well as for the conduction of diode. My dear friend, when we will apply an A terminal as it's at low voltage, B terminal is at high voltage, nobody can trigger or turn on this pair without base current or with base current. Without base current or with base current. This is the most important thing. Now, my dear friend, one thing is finalized. When the polarity change, I current will always be 0. Now, what about next thing? If we will apply negative positive voltage, now can you tell me what will be the reading of V1 and V2 tentative reading? Tentative reading. Okay? Just plus minus 20% error. I will accept. So what will be the reading of V1 and V2 if we will apply minus plus 1 kV voltage across the terminals A and B? Think over it and tell me. In general, in the previous case, now BJT was capable to block entire voltage, because BJT can block positive voltage, diode cannot block positive voltage. That's why. Okay. Now can you tell me answer? Yes, tell me fast. Yeah, think over it and tell me fast. Yeah, very nice. Everyone see properly, my dear friend. This is negative voltage. This is negative voltage. Come here. Come here. This is the beta diode VI characteristic. This is BJT. See, BJT can block positive voltage. So in first case, it was capable. Now diode can block negative voltage. So in second case, diode is capable. So what will be the reading of V1 and V2? What will be the reading of V1 and V2? So V1 will not block any voltage, whatever you will apply. So this 1 kV voltage negative will block by only diode. So the reading of voltmeter V2 will be around 1 kV. Will be around 1 kV. Now tell me, it is clear? Very nice. Okay. So here in this particular case, beta, when the VAB voltage polarity is reverse biased, obviously no current will flow, but negative voltage will block. Negative voltage will block. So now can you tell me, this switch module will work like an positive voltage block, negative voltage block, positive current pass. So it will work bipolar unidirectional switch. Bipolar unidirectional switch. Similar to, yeah, tell me, similar to which device? Anyone? Similar to which device? Yeah, think over it and tell me, my dear friend. Similar to which device? SCR, MOSFET, IGBT, BJT, diode, GTO. Similar to which device? Very nice. Similar to SCR. Similar to SCR. Okay? Absolutely correct. Similar to SCR. Now, my dear friend, I want to ask you very easy question again. See beta, please be serious at this moment. Here we have two combinations. This is the conclusion of the switch module. I want to tell you, my dear friend, we have some SCR in this fashion. Okay, simple SCR in this way. And I want to tell you, my dear friend, some IGBT or BJT in this fashion with series diode. Okay, this is the thing. Now, see the most important thing. The VI characteristic of SCR and the VI characteristic of this switch module, both are absolutely same, if you don't have any doubt. So this can block positive negative voltage and can pass positive current. It can block beta positive negative both voltage and can pass positive current. So here I want to write plus I plus V minus V. Here we can write minus V plus V and plus I. So it is, my dear friend, bipolar unidirectional switch. And this is also bipolar unidirectional switch. What is the most thing, what is the thing, or what is the main difference in between switch 1 and switch 2? In between switch 1 and switch 2. At this moment, dear friend, you have to provide full concentration. Okay? Otherwise, really, it is not easy to understand what are the drawback of switch module or what are the advantage of switch module. Okay? So now you can imagine or you can understand properly. Obviously, with respect to switching, okay, the SCR is better than second switch module, means the series combination of BJT and diode. Why? Because SCR will operate only at single frequency, whereas BJT and diode will operate at different frequencies. Okay, the switching frequency of BJT can never be equal to the diode, but we will try to maintain this criteria so that BJT switching frequency should be similar to diode switching frequency, but practically obviously not possible. Okay, there will be always some difference. So there will be some lagging in between the turning on time of the diode and BJT. Maybe BJT can turn on faster in comparison to diode, but still BJT must have or will wait, okay, for the conduction. Like I want to say, BJT cannot turn on or conduct immediately, okay, without diode. So for the conduction, BJT and diode both must conduct or turn on simultaneously, but practically this thing is not possible. BJT will require less time to get turned on, whereas diode require more time to get turned on. This is the thing. So due to this thing, there will be some switching or delay. So we want to overcome this problem, this first case. Second case, whenever we want to turn off our devices, BJT may be faster device in comparison to diode. So due to this reason, for a certain period, diode will face high amount of current in the reverse mode. So current stress in the second case will be more due to two different switching frequency devices. Now what about SCR? Not like this, because single device is there, so single switching frequency will not introduce any current stress, extra current stress. Okay, this is the thing. Now tell me, dear, all the points are clear till now. Moreover, BJT has secondary breakdown problem. Yeah, Arvind, that BJT has secondary breakdown problem, but we don't want to operate in hard switching mode. We want to operate in soft switching mode. So in soft switching mode, we can avoid the secondary breakdown problem. Okay. So you can realize many times in the IEEE paper or in the laboratory or in industries, okay, related to power electronics converter, they are ready to use, or they feel better to use BJT even sometime, okay, because they don't want to use BJT in the hard switching mode, okay, so that secondary breakdown problem will never occur like this. Okay, this is the first thing. Now, yeah, propagation delay, very nice, beta. So that type of things will happen, but still the switch module is better than this SCR. In which way? The overall switching frequency of this BJT and diode can be the better than our SCR. So my dear friend, here we require less di/dt protection maybe. Okay, so in terms of protection, this second combination is better than SCR. And sometimes according to the power rating, we can use either SCR or BJT. So please never say like BJT and series combination of BJT and diode is somewhat better than SCR. No, my dear friend. Actually, choice and application requirement will tell you which one is better or which one not. Okay. So see, let us assume we want to design one converter and we have used SCR to design that, and we got switching losses 10 milliwatt, roughly 10 milliwatt. But if we want to use in the same converter for the same power rating second switch, and second switch will give us 8 milliwatt switching power loss, so it means second one is better. But now we have checked conduction. So we are getting, let us assume SCR, whenever we are using SCR, the conduction loss is 10 watt. And in the second case, the conduction loss is coming roughly, I want to say, for example, 9 watt or 8 watt, something less than that. So it will be better. If it is happening in reverse way, then first one is better. But just keep one point in your mind. For low power rating, for moderate power rating, BJT, IGBT, MOSFET are somewhat popular. Okay, obviously not BJT, IGBT and MOSFET are somewhat popular. And in high power rating, SCR is popular. That is the point. Okay, so due to all those reasons, we want to design switch module. Now tell me, each and everything clear? Please everyone, tell me fast. Yes. Now I want to ask you one question, my dear friend. Read this question properly and tell me what will be the VI characteristic of given switch module. Okay. So this is example in front of you. I am writing. We have one IGBT in this fashion, IGBT, and one more diode, and again one more IGBT in this way. Okay. So here I want to write, this is some IGBT gate, this is diode, and the IGBT are connected in this fashion. Okay. So this is terminal B, that is terminal A. And I want to write, my dear friend, I want to do another diode in this fashion. Okay. So can you tell me the VI characteristic of the switch module? Yeah, VI characteristics of ideal switch module. I want to give you a few options. You start your job. Okay, you start your job. So A, B, C, and D option. Okay, here. Like this, like this, like this, or that. Yes, start your job. So it is positive I, positive V, minus V. Positive I, negative I, plus V. Positive I, negative I, minus V. Positive I, minus I, positive V, minus V. Now tell me. Okay. So think properly, what will be the VI characteristic of switch module? What will be the VI characteristic of switch module? Yeah. Quadratic, you can think, okay? But definitely we have to reply in ideal way only. Okay, dear? We have to reply in ideal way only. So this is our totally switch module. So we have to draw basically VI characteristic with respect to, my dear friend, VAB or IAB. VAB or IAB. This is the thing. Okay. Chaliye. Yes. So it is overall. How many number of devices are connected? 1, 2, 3, and 4. Yeah, sorry. You have options also. Name A. Wait a minute, beta. A, B, C, and D. Okay. These options you have. These options you have. Yeah. So D, A, okay, A and D. No, I think you are not getting the points. See properly. The most important thing to draw the VI characteristics of switch module. Okay, VI characteristic of switch module. I want to speak very slowly. Okay, there is no big issue. Okay, no big issue. We will discuss. Try to understand better. Here, this is our switch module. I want to cut this portion for the better understanding of our analysis. Okay. So now see properly. I want to plot here beta. Forget about option. Now see properly. Listen to me carefully. It is really very easy. I want to show my dear friend here some positive voltage, here some negative voltage, and total voltage roughly we want to apply 100 volt. Then what will happen? See properly. What will happen beta? When we have positive negative voltage, this terminal is connected with positive. Think properly. This terminal is connected with negative. Obviously. Now positive means at the cathode of this diode D2, positive, and anode is connected with negative. So first tell me D2 will get turned on or not. What we can write? What we can write, my dear friend? D2 is on or off when this VAB is positive. So I want to write case first. When VAB is greater than 0, diode D2 is guaranteed off. Nobody can turn on. Very nice. Diode D2 guaranteed off. Now what will happen about IGBT? Okay, about IGBT. See properly dear. Here we have positive voltage negative. So the positive negative voltage will appear in this fashion. In this fashion, distributed across the devices. But we are not providing gate pulse. We are not providing gate pulse. So gate pulse is absent. My dear friend, IGBT, MOSFET, BJT, all are controlled device. Without providing gate pulse, they are not going to turn on. Okay, so we are not providing any gate pulse. I want to say, dear friend, gate pulse is absent. Gate pulse is absent. Definitely IGBTs will not turn on, so we can say off only. So no current will flow in this case. When we will apply positive negative voltage, IGBT not going to trigger, so all devices are off, so no current will flow either from terminal A to B or from terminal B to A. Okay. Now what will happen? IGBTs are off. Here we apply plus 100 volt. Two IGBTs are there. If they have ideal voltage rating or same ideal voltage rating, then definitely both IGBT will block equal voltage, because diode cannot block positive voltage. Now what will happen in this case? This switch module, totally switch module, dear friend, will be open circuit. So we can draw like this. The switch module we can draw like this. Our first IGBT off, diode is off, second IGBT is off, and this reverse diode is also off. And here we apply plus minus 100 volts. So this volt will come here, plus 50 volt theoretically, plus 50 volt theoretically, and no voltage at this location, because this is IGBT2, and this is IGBT1. And IGBT1 and 2 can block positive voltage, whereas our diodes cannot block any negative voltage, any positive voltage. So either this diode D2 will block entire voltage in this fashion, or IGBT will block positive voltage in this way. But still, no current will flow in any direction. So in this case, my dear friend, VAB will be positive and IAB is equal to 0. Tell me this point is clear. Yeah, tell me fast. Yeah, speak up fast, speak up fast. Till now it is clear. Very nice. Now my dear friend, till now what we can draw in VI characteristics. Okay, let us assume dear, here we have VI characteristic in this fashion. So in our case, no current will flow, so I is 0 and V is positive. So V is positive, so we can write positive V but no current or nothing else. This is the first case. What about second case? See properly here, beta. Now this voltage supply is still positive, but we want to trigger our IGBT. We want to trigger our IGBT. So gate pulse is present. Gate pulse is present. And due to positive gate voltage, IGBT will get turned on. IGBT will get turned on, but still diode D2 cannot turn on. Diode D2 cannot turn on. Then what will happen? See properly. IGBT is trigger. So IGBT on. Now when IGBT on, diode is also on, because all devices are connected in this way. When IGBT on in this fashion, diode will also on, another IGBT triggered, so on like this. So when all the IGBT triggered, diode is also on. Now current will flow from terminal A to B. Hopefully this point is clear. And now it will work like a short circuit. So what will be the voltage? VAB 0, but current will flow from A to B. We can say positive current. Okay. So now in the second case, what will be the VI? Some positive current will flow, but no voltage is there. So plus I. Now tell me dear, it is clear or not? Yes, everyone, it is clear or not? Now I want to consider next case. Okay. So again we want to take this figure and now try to understand. You will tell me, dear, you will tell me the moment at which we will change the voltage polarity across terminal A and B. Now what will happen? Think over it and tell me. Okay, diode D2 will block. Yeah, diode D2 will block 100 volt. Okay, definitely. Now I want to ask you very simple question. Let us assume dear we apply minus plus 100 volt here. Then what will happen? Just think properly about the circuit or switch module. I promise you, definitely you will learn. Okay, or you can reply. So according to your friend, maybe D2 will turn on. Okay, any other choice, my dear friend? This is D2, this is D1. Yeah, everyone, I need answer. What about beta Poonam? You tell me. Everyone, think properly. What will happen? See, here minus beta, here plus. So plus will come here, minus will come here. Everyone knows it, my dear friend. When anode voltage of diode is greater than cathode, nobody can stop the conduction of diode, because diode is fully uncontrolled device. What about MOSFET, BJT, IGBT, SCR, etc.? These are controlled devices. They are not going to turn on without triggering, okay? But diode is free from triggering. It is totally uncontrolled device. So the moment when we will have cathode voltage greater than anode, nobody can stop the turn off process of diode. If the anode voltage greater than the cathode, nobody can turn on, nobody can stop turn on process of diode. So here, my dear friend, when this is positive, this is negative, instantaneously our diode D2 will on. Now see, it is really very easy beta. When this diode D2 is on in this fashion, definitely the voltage VAB will be 0, because it will work like short circuit. And now current will flow in opposite direction. Earlier it was flowing in this way, BJT, diode and BJT or IGBT. Okay, so this current will flow in this way. So one current is flowing A to B, another current is flowing B to A. So you are like, it is clear to everyone, I think. So now the answer is nothing but current will flow in opposite direction. So due to this reason, my dear friend, we can write minus I and no negative voltage, So what will be the final VI characteristics? Positive I, negative I and positive V. So this is the thing. Now, according to this analysis, which option will be correct out of the given? Okay. So see properly. The correct answer is nothing but B option. Okay. Now can you tell me you are capable to understand or not? Now can you tell me you are capable to understand or not? Yes, tell me beta fast. Yeah, sure. So can I give you next example for the better understanding? Now, dear, please try to understand. I want to make a bit change here in the previous example. Okay, so please try to understand. Again, you have all options, my dear friend, but this time I don't want to give you this switch module. You have to think over it. Okay, what will be the VI characteristic of this module? Wait a moment. You have one SCR in this fashion and one diode in this way. Okay, now tell me, dear, what will be the VI characteristic of this switch module? What will be the VI characteristics of this switch module? Yeah, start your job, my dear friend. Like, take this example in easy way. Really, it is not complex at all. Okay, so think properly. Think properly. Okay, before drawing the VI characteristic of this one. And again, you have few options. Yeah. What's it? In second case, diode will block minus 100 voltage. No, dear. Yeah, Ganesh, good afternoon. Now, Vijay, why you are not correct? You are not correct at this moment, because diode can block voltage only when it is reverse biased, and once it is forward biased, it will not block any voltage, and even we don't want to allow also. Now, when our diode will on, the entire voltage, whatever we will apply across the terminals, will appear across the load. So when devices are on, those devices are not responsible to block any voltage. This is a simple thing. They are not responsible to block any voltage. Okay? Yeah, now tell me. Yeah, now please, dear, try to understand first the VI characteristic of this switch module, then tell me which option can be correct according to the VI characteristics. According to the VI characteristics. Yeah, option B, very nice. Yeah, any other thing, dear? Everyone tell me. Think over it and tell me. Yeah, B. Okay, take some time, no issue. Take some time, no issue. Yeah, okay, no issue. Now see, first tell me, my dear friend, SCR is controlled device or uncontrolled device? Everyone, tell me, SCR is controlled device or uncontrolled device? Think properly. Now, if your answer is, sir, SCR is controlled device, now see, very easy. We apply, my dear friend, here positive voltage, here negative voltage. So obviously this diode will not turn on because positive at cathode and negative at anode. So diode is reverse biased. And SCR is controlled, and we are not going to trigger. Roughly, we are not going to trigger. So if SCR of diode of this positive voltage will block by this, so here we require positive voltage, my dear friend. So this can be correct, this can be correct, this can be correct. Till now this point is clear or not? Everyone please. Yeah, semi-control means controlled. At this moment I am considering beta. Okay? Yes. Now listen to me carefully. Next point. Beta, when this voltage positive, this is negative, SCR is forward bias and we provide triggering. So SCR is on, current will flow in this fashion and voltage zero. So my dear friend, current will be positive and voltage zero. With respect to the second analysis, positive current correct, positive current correct, positive current correct, positive current correct. But this example cannot be correct, so I am crossing this one. Okay? So positive current possible, positive voltage possible. Now what about next thing? When we change the polarity of this supply, here minus and here plus, immediately what will happen? Plus will appear here, minus will appear here. So definitely plus minus diode is on in a reverse direction, and once the diode is on, it will be short circuit. So negative current will flow, but negative voltage will not block. So negative current will flow. This one correct, this one correct, but negative voltage will not block. So wrong and wrong. So finally option B is correct. Done. This is the only question. Hopefully it is clear. Now I want to take another example for you. Okay. Please read this example carefully. Read this example carefully. Okay. And tell me VI characteristics of switch module. Don't consider entire example. Leave the example, leave the example. Just tell me VI characteristic of this switch module. Only VI characteristics of ideal switch module. Start your job. Ideal switch module. And here I want to give you few options. Okay. Option A, B, C and D. Okay. So plus I plus minus V and something like this, and this one and this one. Only you have few options like this, and I want to write it is option A, B, C and D, and this is plus I minus I plus V minus V. Here plus I minus V plus V. Here plus I minus I plus V minus V minus I. Okay, you have these options. Yes, now start. Try to understand first example or switch module properly, then tell me the correct answer. Yeah, take some time, no issue. A, okay. Very nice, very nice. Yeah, Anik Himanshu, do one thing, now handle complete question. Now handle complete question. And tell me losses in the BJT. Tell me losses in the BJT. Okay. Now see, dear everyone. Wait a minute. By which way can I tell you this thing easily? Okay. Now see, Betaji. I want to write here this thing. This is positive and that one is negative. Now see properly everyone. Now, if it is positive and that one is negative, here we have one BJT also. Here we have one BJT also. Okay. Here beta, we have one BJT also. See, I want to increase the size of the device in this way. Okay. Now, I think it is visual properly. Now, my dear friend, I want to write plus minus here. And we have some BJT, and BJT is controlled device. One job is clear. BJT is controlled device. Okay. Yeah, sure. 1 volt. I will do same thing today. Yesterday also we have discussed only the concepts. Okay, not examples in the evening session. Now see my dear friend, this BJT is control device, we know it. The moment when we will apply positive here and negative here, see properly what will happen. This diode D1, I want to give some name, D1, D2 and D3, D4. Yes, dear. Now this device D1 is a start to conduct, but this BJT will oppose. Similarly, this device D2 will start conduct, but this BJT will oppose. So my dear friend, see properly. Few things. The diode D1 and D4 cannot conduct simultaneously. The diode D3 and D2 cannot conduct simultaneously because anode and anode are common. Similarly, here cathode and cathode are common. So either conduction possible in this way, you are getting my point? Either conduction is possible in this way, or my dear friend, conduction is possible in this way. Okay, in this way. So when we trigger our BJT and this voltage is positive negative, D1 D2 on with BJT, so current will flow in direction of yellow color in this fashion. Okay, and when we will change, my dear friend, polarity here, opposite, minus plus something, what will happen? In this case, we want to trigger BJT, so current will flow by the pink color. Now tell me, this thing is clear? This thing is clear to everyone. Now this given device will be bidirectional one thing. Bidirectional one thing. Okay. Now what about second thing? See properly here. Okay. I want to write again, my dear friend, here positive voltage and here negative voltage. But we are not triggering BJT. We are not triggering BJT. Then all the devices are off because circuit cannot complete without BJT. So now this terminal A and B will face same voltage. So now voltage blocked by device is positive. And the moment when we will apply negative and positive voltage, and still we are not turning on BJT, so BJT off. Now beta, BJT off, it means all devices are off because conduction not possible. Without BJT, in this case, what will happen? Entire negative voltage will block by our switch module. So this switch module can block positive voltage, negative voltage, can pass current in either direction, either in this fashion, yellow color, or my dear friend, either in this fashion, green color. Okay, in any way conduction is possible. So it is a bidirectional bipolar device. Bidirectional bipolar. That means the option A is correct. Hopefully this thing is clear. Now tell me. Yes, everyone, dear. Yes, everyone, dear. All the points are clear. So by this way we can draw VI characteristic of switch module. And tomorrow, my dear friend, we will discuss numerical example of switch module as well as VI characteristic of many switches, so that you must be familiar with the switch module, because my dear friend, you can say almost more than 90% probability is there. In the gate 21, they can ask one question from this section, either VI characteristics or conduction loss or switching loss. So all the points are really very, very important for the upcoming gate. Okay. Yeah. So thank you, dear. We will meet tomorrow. If you have any doubt, please let me know. Yeah, tell me fast if you have any doubt related to switch module, VI characteristics, switching losses, conduction losses, switching frequencies, anything. Yeah, tell me fast, everyone. Okay, so we will meet tomorrow, my dear friend, at 11:30, same timing, or it will be good or better for you if you have to complete just gate previous year examples. Okay, hardly in gate we have 6 to 7 examples related to VI characteristics. So just complete all those examples. Now you are capable to do, and after that we will discuss different type of examples related to switch module. Okay, yeah. Himanshu, dear, I don't have any answer beta at this moment, but tomorrow we will discuss same example with this numerical, with entire numerical things. Okay, yeah, thank you.